Hey everyone, I'm Utkarsh and today I'm going to show you how I built an autonomous end-to-end LinkedIn content agent designed specifically for B2B enterprise audience. Before I start, I just want to apologize regarding my voice. I'm running under the weather a little, so please don't mind. So most people build content automation tool go the obvious route. They just scrap the generic tech news or the trending AI headlines and dump into the LLMs. And they just call it a day. But if we want to build something that actually drives impact, we have to target the exact pain points that the VPs or the CTOs or any executive buyers actually care about. So let me show my work. Yeah, so to make this completely production grade, I'm running this entire multi-agent orchestration on a self-hosted n8 instance using Docker, completely backed by local PostgreSQL database for deep state management and data retention. So instead of generic fluff, I targeted two ultra high value content streams that kept our funnel active. So let me show you how it works. So here we have our data flow workflows, and the two places where I'm fetching data are like the earnings and the regulatory tasks. So the first stream is the earning call coverage. Every quarter, public companies get on a calls with analysts and talk about their AI investment, their ROIs, their struggles. This is gold for LinkedIn content because it's the real data, not opinion. When a CEO says that we are seeing 80% of growth from the AI agents, but our margins are shrinking. So that is a LinkedIn post that writes itself. The second one is the regulatory updates like the EU AI Act, the NIST frameworks, the FTC enforcement actions. The enterprise buyers are genuinely worried about the compliance. A pipeline that catches these updates and turns them into a plain English LinkedIn post positions anyone using it as go-to person who translate it into an engineering reality. So together with these two streams, we ensure that the pipelines never runs dry. Earning calls happens every week during the earning season and the regulations are moving faster than ever. So I believe it's a good idea for a scheduled LinkedIn post. So let me give you an overview of the whole architecture. So for this architecture, I decided to build and orchestrate this entire pipeline on a self-hosted n8 instance where running via Docker, hooked up to a local PostgreSQL database for memory management. And I prefer this setup because it gives me a complete control over the execution environment and the data privacy. So let me first walk you through the high-level architecture before we go to the node by node structure. So the system has two independent flows, as you can see. Yeah, so this is the first one and this is the second one. So the top row is the content generation pipeline. It runs on a 6 hour schedule. It fetches like RSS feed, check for updates against a Postgre memory layer, generate a LinkedIn post using the Gemini with personal brand DNA config, creates a matching visual, and then sends everything to Slack and Gmail for my review or like the human in the loop review. And nothing post automatically, it will always stops and wait for my approval. The bottom row is the approval and the publishing pipeline. This is a complete separate trigger and it's a webhook. And when I click on the approve in my email, it hits this webhook, this one, and it validates the request with a security token, updates the database, and then posts directly on the LinkedIn with the text and the image, and then finally sent a notification on the Slack. So now let me walk you through each node so that you can see exactly how it works. So on the first workflow, as you can see here, this is a schedule trigger, and the pipeline kicks off when a schedule trigger is set to every 6 hours. In production, we would have to tune this based upon how much we want, like how much the content is being updated, maybe twice or thrice a day, like 8 a.m. or 2 p.m. or any time that is being, most relevant here. Second is the init initialization run. So it it creates a unique ID and a timestamp. This is just for housekeeping, and it lets me trace which pipeline run produced which content, and if something goes wrong, which execution log I have to look into to debug. Then the third, after passing through this, we have like our source monitoring, the earnings part, and the regulatory part, which I already told you a little about. So here, the pipeline fetches from the two sources in parallel. The node hits CNBC earning RSS feed. I have like 30-second timeout configured. So if the feed is slow, it does not hang the entire pipeline forever. Show you how it looks like. And we have this run ID, the URL of the CNBC. This is what the XML it fetches. The similar thing is happening here for the regulatory part. As we can see that the XMLs are being fetched here. So both of the process are like running simultaneously, and the second one, like the regulatory one, which is from the NIST news RSS feed for regulatory updates. And even if one of the portal is down, uh, one will still work and still produce the result. So now I'm also handling the error parts, like if you'll notice that these are the safety nets basically. If a fetch fails, let's say timeout or 404 or server down, these kind of errors, the error handler catches it, logs it, and return the empty one. The other stream continues normally, and the pipelines never crashes because even though one feed has a bad day, the other will still continue. So this is the logical resilience part for the evaluation criteria. We can say that. And so this was the fetching part. Now the parsing and the filtering part. So the raw RSS response come back as XML. The code node parses it and extract the title, the URL description, the published date from each article. Let me show you. I have set it the max to one item per stream, and this keeps the things manageable. One earning post and one regulatory post per cycle. Similarly, here also, same parsing logic for the regulatory feed, but with one extra step is like keyword filtering. Here we are doing this keyword filtering part. Like not every NIST article is about AI. So this node checks if the title or the description contains keywords like AI, artificial intelligence, machine learning, cybersecurity, AI governance. And if it does not match, then we silently drop it and only the relevant content pass. So this can be a good example of a modular design and a dynamic design, you can say. And if we want to add more keywords, we just have to change our filtering logic and nothing else in the pipeline needs to be changed. Okay, now the deduplication part, memory and prevention, you can say. So the both the streams merges here, and every item gets a unique hash generated from its title plus URL. This hash set is like the item's fingerprint. it is how a pipeline knows, have I processed this before or not. So I think has set is a perfect data structure to use here. Let me show you this one too. So here we are handling the both the URL and the name, and we are adding it and keeping it as a hash key. Similarly, now we go to the memory gate now. So for each item, it runs a SQL query against the pipeline memory table in Postgres. Does this by the hash that's already exist. The query uses the count, so it always return a result. And if the count is zero, it let me show you this. Yeah, the query uses count, so it always return a result. And if the count is zero, it's a new item. And if the count is greater than zero, it's already have been processed. So I want to call out something important here, like the Postgre node in the n8n replaces our input data with the query result. So if we are not careful, we're gonna lose all the original data after this step. So I solve this by including all the original fields as the literal values in the select query itself. And that way the title, URL, the source type, everything survives to the database check. It is a small thing, but I think these kind of things really matters in the production. Now the next part is for the duplicate part, the filter for the duplicates. So let me show this, and this code nodes reads the duplicate count. If greater than zero, it returns nothing and the item is silently skipped. And if zero, it passes the item through with all the original data intact. And this is the memory and prevention constraint in action. No article get processed twice, so no duplicates post ever gets generated. Yeah, and now the most interesting part here is the brand DNA. So yeah, why this is the interesting part? Let me tell you. So this layer, the brand DNA layer, contains one of the three core constraint. All right. So instead of letting the AI write itself its default generic voice, this node this node loads a configuration object that defines exactly how I write on LinkedIn. It's like taking my personality and always be in that domain. So it takes my tone, direct, slightly contrarian, practitioner perspective, my hook style, always open with a surprising stat or uncomfortable truth, my sentence structure, short and punchy, maximum 2 sentences per paragraph, words I never use, like leverage, delve, and how I close the sentence, always with a quiet quotation, question, never a hard sell. So all these personality things, all these things get ingested into the AI prompt as a non-negotiable rules, and the result is in that the every post sounds consistently like me, not an AI. And this is the key architecture point. The brand DNA is a separate config. If something else wanted to use this pipeline, or if someone else wanted to use this pipeline, they just swap their personality traits into this config node and the whole module will be the same. Only these things can be changed, and this can also show the modular or the dynamic design system. So we can basically say that it is a little fine tuning kind of stuff. Okay, so now we're done with the brand DNA part. Now comes the agentic part, and the prompt, whatever which being generated till here, is it hits the Google Gemini now. So I'm using Gemini as my LLM because I already had my credential configured from my previous projects, and it helps me to save time a lot. The system prompt tells Gemini to return a JSON object with two keys: the post key, the post text with and a visual prompt for image generation. So one AI call produces both the content and the image description, and that will be very efficient as we are making going to make an API calls on schedule. Let me show it how it is working. Yeah, so we have our text. This is how the prompt which I have written here, and it is going to produce a JSON object with post text and visual prompt. Post text will be the textual part, and the visual prompt will be the prompt, the description of the image that needs to be created. All right. So this is all be happening in one go. So, and also the node also have the retry logic enabled. If Gemini hiccups like the rate limits or the temporary outage, it waits 2 seconds and try again automatically. And that is another resilient feature, which we can say. Now the next part, when the LLM has given its response, then we have to extract that content, right? The node parses the Gemini JSON response, strips any markdown formatting that might have been snuck in, and separate the post text from the visual prompt. It also pulls the original data back from the upstream using a node reference. So after this node, we have everything: the hash, the title, the source info, the drafted post, and the image prompt, all in one clean object. This is the JavaScript where it is written. You can see how everything is being segregated: title, the post text, the visual prompt. Yeah. Now the next part is the generate visual. So this takes the visual prompt that Gemini created and construct. So we are using here the pollination.ai. It's like it's a place where the the diffusion is basically a diffusion model where we can give the prompt and a generic basic image is generated. It's a free platform, so we don't expect it to be creating a very high quality image, but I think it's fine for our use case for now. So it's a free image generation API, and we can encode it in our prompt into the URL, and it generates the image on the fly, and we don't even need any API key for this. So in the production version, we can swap this with the DALI or the Mid Journey with a branded template. But I think for the demonstration part here, pollination works. So now is the part after the visual is being generated, after prompt being extracted from the extract content and the visual is generated, we go to the build notification part. So this is basically the assembly node. It takes everything: the title, the source, the post text, the image URL, the hash, and builds two notification format: a Slack message for quick awareness, like to approve or reject, and a full HTML email with the article metadata and the generated visual, the complete draft post, and the approve and reject button as on the Gmail. So let's see. So when the notification is being built, we're going to save it to the memory, and we are going to notify the user that check your email and approve or reject whatever the draft is being presented to you. So one point I also want to add here is like it also generate a secure webhook URL for the approve and the reject action. Each URL include an HMAC token, a hash set of the item's hash combined with a secret. This means that we cannot approve a post just by guessing the URL. We need to have the correct token, and this is like the security part we need to take care of. All right, so this is about our first pipeline, initial pipeline. Yeah, one thing I also want to add uh, or demonstrate a little more is about this memory part, is because before sending notification, the items get inserted into the pipeline memory with the status of pending approval. The post text and the image URL are also stored here. This is important because when the approval comes later, maybe hours later, the webhook needs to retrieve the content. It fetches it from this table. And similarly, this is the Gmail part. You can see how the Gmail is going to be here. The body will be go with the image part and will be stitched together and send it as a mail. So both the notification file in parallel, the Gmail will get the full HTML email with the preview and the button. The Slack will just get a quick ping to let the user know to approve and check their Gmail. And the pipeline stops here, waits, and nothing posts until the user or the human in the loop explicitly click the approve. So this is the human gatekeeping part, and this is where it is being paused because a manual approval is required. All right, so this is the end of our first first flow. Now we're gonna go to this our second flow, that is the publishing flow. So let me show what happens when I approve. So this webhook, sorry, listen for the incoming approval request. When I click the approve button in my email, the browser sends a get request to the URL with the three parameters: the items hash, the security token, and the action, like to approve or reject. All right, so go to the validate token then. So the first thing is the security validation. This node recomputes the expected token from the hash and the secret and the compares it to the what has been sent. If they do not match, the request is being rejected. This prevents anyone from spoofing an approval. And we would also need to know which secret to generate a valid token. Now the routing part. So if the action is approved, it go to the approved part. If it is being rejected, it's go to the rejection part. Both hit the same database and the update node. So this is one SQL query that does the two things. It updates the pipeline memory to set the status to approved or rejected with a timestamp, and it inserts a row into the pipeline audit, a permanent record of the decision. And this audit trail mean I can look back 6 months from now and see exactly what was being approved and what was being rejected and when. So this is the memory part. Now the send response, sorry, the spelling mistake. Yeah, so if it was an approval, the flow continues. It fetches the post text and the image URL from the Postgres, download the actual email file from the pollination URL, and then post to the LinkedIn via the LinkedIn API with the text and the image visibility set to the public. So as you can see, send request, if it is approved, is fetch the post assets. That means take out the text and the image from the pollination and then post it on the LinkedIn and send the user a notification that the post is being there on the LinkedIn, is active. So this is how the second workflow, the publishing workflows, works. So now we have both the workflows there. And these are the things which I want to add are the earnings like and the regulatory errors. These are the error handling parts, and it will just send it to the global error catcher, which I have set it here. You see we have this global system error handler which I had made, and it catches all the errors and send me on the Slack. All right, so let's start the demo how the whole things work so that you can see end to end the cycle how it works. All right, so first let me clear the memory table from here. See how it's going to be. LLM is generating the result. Okay, so it is running twice because it's for earning and regulatory. Earning is done, regulatory is being is fetched. Then we'll going to get two emails, the Slack notification for that. So let it run and then I'll check. All right, so now we have to see the Slack. Content approval is 2:21 a.m. 3:22 a.m. Yeah. So we get the notification here on the Slack. Now let's go and check our email. So let's refresh the email. Yeah, we got two emails. Okay. And this is the post and the image that is being generated by the pollination AI. As we can say, that is a free diffusion model, so I can't expect a very good image, but still it's a little that we can work for now. And let me approve it. So if I click approve, see what happens. See, decision recorded, pipeline updated. All right, this was the earning part. Let's take the regulatory part. What it is being generated here. See, another image being generated, NIST regulatory, and we have the draft post being generated according to the article which it has seen, and then we approve this too. All right, so this is being approved. Okay, and now we can see there is 2:23 a.m. We have the approved post is on live. It's now live on the LinkedIn. So I received the message from here. It means the post is already being there. So let's go and check our new post. And we can see our LinkedIn also that the post is being posted here or not. We can see at 1 minute before these two posts is being posted here already. You can see that with the same image and the text, the NIST one text got here also we can check that. Just 2 minutes ago. And yeah, it was already got 6 impression and 2 likes. It seems like it's working fine. So the pipeline ran, and as we can see that the data flew through each and every node. The RSS feed are being fetched, the items being passed, hashes being generated, memory checks are there, and the brand DNA, like the prompt which take care of our personality trait, is being injected, and then the Gemini is drafting the response, visuals are being created, notifications are being sent, and then it went for the approval, and then we saw the email, and after the email approval, it goes to the generational part of the pipeline of the workflow, and accordingly the pipeline is being updated. And in the database also, the status is now being approved with a timestamp, and the audit log has been recorded. So if I run the pipeline again now, the same articles will be skipped because the memory layer has already has them. So let me recap the whole thing, like how this addresses the all the evaluation criteria that should be there. First is the logical resilience. Every external dependency has a fallback. RSS feeds have error handlers, so one broken feed does not crash the other. The AI model has the retry logic. The Postgre memory check has always the output data enabled, and the pipeline is designed to degrade gracefully, not fail completely. The modular or the dynamic design part is like every component is independently swappable. Like if we want to switch from Gemini to cloud or change, we just have to change one node. If we want to add a third content stream, let's say a Reddit or archive or something, then we just have to duplicate and fetch and parse the pattern. We just have to duplicate the fetch and parse pattern. And if we want to do anything changes in our personality trait or the brand DNA part, we just have to edit one config object. Similarly, we can swap the Gmail for Telegram or any other notification node according to our need, and we can easily extend our architecture in that sense. For the security part, all the credentials like the Gemini, Slack, Gmail, Postgre are stored in n8n encrypted credential vault. Nothing is being hard coded in the workflow, Jason, and the approval webhook validates the HMAC tokens, as I explained earlier, also on every request to prevent spoofed approval. And the whole thing is like I implemented and also maintain a version note of it on the GitHub. So we have our all three constraints. The human gatekeeper is the Slack plus the Gmail approval gate, which the webhook pause with the webhook pause. The memory and the prevention is the SHA hash based deduplication, which I already explained against the Postgres. And the brand DNA is the swappable style configuration injection according to the personality traits, which we can inject to every AI prompt. So thanks for watching, and you can check the GitHub for the implementation. I have written everything in the detail and all the implementation in a structured format. So thank you very much.